Hello and welcome to the MethodsCore tutorial for Quality Checking Suite. Suite is located in your repository on the QualityChecks folder. Inside the folder, you'll see that there are 5 toolboxes in this help folder. You'll definitely want to go inside this help folder and read the documentation for each toolbox before using them. In this whole tutorial, I will be only going over 4 of the quality checking toolboxes: the checkSlice, check motion, check reg, and finally the check frame. In this video, I will be going over the checkSlice toolbox. The checkSlice toolbox is intended to be run over the raw 4D run images. It's used to detect if there's any spikes in any slices, so the user can take appropriate action before any pre-processing. So if you look inside the folder, we can see all these files, and then we also see the template and central file. So it does have the template and central file scheme, as do the rest of the quality checking toolboxes. So what you want to do is make a copy of the template file, which I've already done, and so I'm going to change the directory to where I copied it. And now if I open it up, we can see it's pretty similar to the first level, which we've already released. In that you set the values for each variable, and each variable is heavily commented, so hopefully it's self-explanatory. So for the first variable, the app.exp, it's the folder that contains your subject folders. So I've already filled this out, so that's my value. Next is the subject list. It's pretty much the same as from the first level, so you can just copy that from here. The subject number isn't really used, so you can put any number at this point, so it shouldn't really matter. But ideally, you would want to use the same number in your master data files so that you can just copy and paste. The next are the list of runs. Then we have the image template. So this is just the path where your images are located. The scan of the next variable sets the prefix of the scan of the images to use. As I mentioned before, this is supposed to be used over the raw runs, so we're just using the run. The next variable sets the value where the text file for the output detected slice outliers should be written. And the final value is the z-score threshold. Slices with absolute z-scores greater than this value will be considered as outliers. The recommended value is 4. If you increase it, less slices will be detected as outliers, and conversely, if you decrease it, more slices will be detected as outliers. So to run it, we can just type the template name in the MATLAB prompt. So we'll see all this information that it's calculating the metrics for the subject and the given run. So I'm going to pause the video here because this might take some time. Okay, so it looks like it has stopped running. As you can see, like I mentioned before, it tells which subject it's calculating the metrics and then which run. Then when you know it's done, it'll tell you that it's all done. So let's take a look at the text file. So this is our slice wall of shame. So it displays each slice that was over our threshold of 4, or our z-score threshold of 4, as we can see in this column, for each for the run file. It also displays which slice and the time point, and it also displays the mean squared error between the slice and the previous slice, but between the difference of our slice here and the previous slice. In the actually it's the mean squared error between the same slice at different time points, so it should be between the 121st and 122nd. So generally, if both the z-score and the mean squared error are high, there's probably definitely a spike in that run. For instance, in this one probably definitely has a spike. And then the user can also review these images just to confirm whether the spikes exist or not. Just to make sure that these aren't all false positives. So I'll bring up this image. Oh, didn't want to do that. Just so we can see what's going on. The image quality isn't really that great since I'm kind of on a wireless connection and signed in remotely. Slice 7, 12. Oh, whoops, this should be 12. And then let's look at time point 139. Let's see if I can improve this quality a little bit. Okay, there we go. Oh yeah, I should mention that these metrics are sensitive to movement as well. So some of the slices may be just deemed as outliers just because of the movement. So let's see. Looks like there's a lot of movement between volume 138 and 139, so it could be largely the reason why it's detecting that as a slice outlier. Yeah, because there's, I mean, we can see between the two volumes that there is a lot of movement. So I think that it's mostly due to movement. I really don't see a spike there. Just checking if there's any other huge outliers. Well, there's also a function in the quality check folder that we can use to parse this text file. So if we go to yeah, the function check images, if we use that to parse, if we call this function with the outlier with the output text file with all the outliers, it'll parse this text file. It'll bring up exactly what's in the text file for each of the images, so that the user can, it's supposed to be intended to allow the user to automatically go through the images and check the quality if they want to. I suggest probably just clicking this movie button and then going through, or well, yeah, you can go through the whole thing. Then if you close it, it'll bring up the next image in the text file. So that concludes the checkSlice toolbox. In the next video, I'll be going over the check motion.